So the next type of inequality we're going to be talking about is called rational inequalities. Again, we have the two methods, graphing method and the sign test method. So the big difference between polynomial inequalities and rational inequalities is, for the graphing method, how you graph it, and then for the sign test method, how you pick your boundary points. But other than that, it's basically the same. So step 1, make one side equal to 0 if it isn't already 0. Step 2, let the f of x be equal to the rational expression, just like we did on the polynomials. Graph the rational function including the following steps at a minimum. So you definitely need to find your vertical asymptotes while you're graphing. Notice it's asymptotes, meaning they could have more than one. You need to find your horizontal asymptote if you have any. Then you need to find the x-intercepts. Notice that the y-intercepts are not in this list, but if you want to get them, you're welcome to get them to get more points. And then for part D, we need to plot more points if necessary to get a smooth graph approaching the asymptotes. Step 4, mark the positive and negative y values on the graph, just like we did with the polynomial inequalities, and mark on the graph where the inequality is satisfied. Then on step 5, the solution is the x values, same as the other inequalities we've done, or the domain, the x values, where the inequality is satisfied, answered in interval notation. The steps for the sign test method are make one side equal to 0, just like we've done in the past. Step 2, let the f of x be equal to the rational expression. Step 3, find the boundary points. Now this is the part where it's a little bit different than the polynomial, which are the vertical asymptotes and the x-intercepts, or zeros if you want to call them zeros. Evaluate the point at each interval and mark the signs on the number line. Note that the vertical asymptotes will never ever be included. Vertical asymptotes aren't 0, there aren't x-intercepts like in the polynomials, but the vertical asymptotes are not defined there at all for the rational expressions, so therefore they can't be included in your answer. So the solution to the inequality is the x values, or the domain, where the inequality is satisfied. Don't forget you have to answer in interval notation. So let's try a few. For the graphing method, I'm going to try to find the vertical asymptote, which is where I set the denominator equal to 0. Notice there's no canceling, so we don't need to worry about holes or anything. So we have x is equal to 2. The horizontal asymptote, that's the chart. That's where I compare the degree. Because the degrees are the same, I'm going to take the leading coefficient divided by the leading coefficient, and 1 divided by 1 is 1. The x-intercepts, so that's where I take the numerator and set the numerator equal to 0. So when I set x plus 5 equal to 0, I get negative 5. And let's see if I can graph what I have so far. I've got a point at negative 5, 0. That one point will tell me a whole lot of the graph. I know that my graph has to approach the asymptotes. And on the right side of the vertical asymptote at 2, I either have a branch down here at the bottom or I have one here at the top. To figure out which one's which, I could use a point, but there's another way I could do this. I know that there's only one x-intercept. Don't draw this part, but if the branch was at the bottom, notice it would have another x-intercept, and it doesn't have another x-intercept, there's only one. Therefore, the branch must be in the top. Now if you're not sure, you can always plug in a value like 3. So that gets me 3 plus 5 over 3 minus 2, which is 8 over 1, which is still positive. So I would have a point at 3, 8, and therefore the branch is above. But I think you can probably just realize that it's above the horizontal asymptote because it's not allowed to cross the x-axis. Next, I want to mark the points on the graph where is above the x-axis versus below the x-axis. So anything that's above, notice that the x-intercept at -5 means that the branch over here is actually positive until you reach 5, which is 0. Then it goes negative for a while. And then the entire branch on the right-hand side is positive the whole time. So now I want to identify which branch satisfies my inequality, where f of x is greater than or equal to 0. So where is it greater than or equal to 0? Well, greater than means positive, so anything that's positive gets to be included, and 0. So notice we have a 0 right there. So we have two branches that actually work. My domain would be from negative infinity until -5. Do I get to include the 0 right there? Well, sure I do. Union with all of the values on the other branch. Now this branch goes up forever here and it gets to be included, but it never actually reaches 2. So we have 2 till infinity, but because it never reaches 2, I'm not allowed to include it. You're never allowed to include the vertical asymptotes, because the vertical asymptote means that it's not the rational function is not defined there, so therefore you can't include it because it doesn't even make sense. It's not defined there. Let's do the same problem with the sign test method. The vertical asymptote again is the same, using the same rule where the denominator is equal to 0. The x-intercept or zeros is at -5. That's where you set the numerator equal to 0. So at 2 and -5 I have boundary points. At 2, we have a vertical asymptote. At 5, we have a 0. But I still need to work out the 3 branches, so I'm going to find something to the left of -5, which we'll choose -6. So we'll go ahead and plug that in. I'm getting -1 over -4, which is positive. Then I'll try the next branch, which will do something between -5 and 2. Let's try 0. 0 plus 5 over 0 minus 2. That's 5 over -2, or negative in this branch. And then in the last branch, I have f of something to the right of 2. We can pick 3. So that's 8 over 1, or 8, which is positive. So for this problem, notice it's different than the last problem. My inequality is f of x is less than 0. It is a different inequality, so therefore there's a different solution. I'm wanting to know where is this less than 0. So less than 0 is negative, but not including any zeros. So in this case, I'm going to have my solution be from -5 to 2. You can't include 2 because you can't include the vertical asymptotes. You don't include the -5 for a different reason, okay? Because the sign is strictly less than, that's why you don't include the 0. For our next problem, we have, for the graphing method, to find the vertical asymptote, I set the denominator equal to 0, so that gets me x is -2. For the horizontal asymptote, I do the chart comparing the degrees. The degrees are the same, so then I take the leading coefficient -1 over the leading coefficient 1, which gets me reduced to -1. To get the x-intercepts, I set the numerator equal to 0. If I set x minus 3, negative x minus 3 equal to 0, and solve, I'm getting -3. So I have a point at -3. I've got a vertical asymptote at -2, and a horizontal asymptote at -1. That means that one point tells me this picture, And because I don't have any other x-intercepts, I know that I can't have a branch where there's an x-axis. Don't draw this for a second. If I had a branch up here, it would definitely have an x-intercept, and there's only one x-intercept, and that's at -3. So therefore, I know my true branch will have to be at the bottom. Go ahead and draw that part. If you're not sure, you're always welcome to plug in a value. Let's plug in 0. -0 minus 3 over 0 plus 2. That's -3/2, which is negative, and definitely it's a little bit tighter than what I drew it. I guess I could draw that again. -3/2, that's way up here, so it's real tight. Either way, it doesn't really matter, because when you come in and put your values in, all of the values that are below the x-axis are negative, anything above the x-axis is positive. So even if I didn't draw this graph that well the first time, notice that the whole thing was still below the x-axis. It's still going to get negative signs. Okay, now I need to determine where my function is satisfied for the inequality. This particular inequality is less than or equal to 0. So where is it less than or equal to 0? So less than says negatives, including the 0, and then this entire branch is less than 0, so I get to include that entire branch as well. So my solution is -infinity all the way up until -3. Do I get to include the -3? Yes, because it is a 0 and it's or equal to. Union, then I have this entire branch over here. Now that branch gets really close to the vertical asymptote. The vertical asymptote starts at -2 to infinity. But notice that because it's a vertical asymptote and it's not defined there, I can never include the vertical asymptote. Maybe you want to make a note there, never include vertical asymptote. Okay, let's do this similar problem. We have f of x is equal to the -x minus 3. Okay, and my vertical asymptote is x equals -2. The 0 is where the numerator equals 0, which we already said was -3. So I have boundaries at -3 and at -2. So I need to plug in values in all three of my branches. Notice that the -2 is a vertical asymptote and it will never be included, whereas the 0 at -3 is a 0 and may be included depending on the sign of the inequality. So I need to pick something to the left of -3, so I'll pick -4. So we have the opposite of -4 minus 3 over the opposite, or -4 plus 2. So that's +4 minus 3. I'm getting 1 over -2, which is negative. So I need to pick something in the next interval between -3 and -2. There aren't any whole numbers between -3 and -2, so I'm going to have to pick some sort of decimal. I'm not actually allowed to pick -3. I already know that's 0. I can't pick -2. That's the vertical asymptote and it's not defined there. So I'm going to pick -2.5. Normally I don't really like picking a decimal. I would normally pick a fraction, but because this problem is already a fraction, it would be a little difficult to do another fraction. So we have the opposite of -2.5, which is 2.5 minus 3, which is -0.5. Most importantly, that it's negative. -2.5 plus 2 is -0.5. And negative divided by negative is a positive. Next, we have to pick something to the right of -2. I'm going to go ahead and pick 0. -0 minus 3 over 0 plus 2. I'm getting -3 over +2, which is negative again. Now let's find out where my inequality is satisfied. So my function is, where is f of x greater than or equal to 0 for this particular inequality? Greater than or equal to 0. That means positive things, or 0. Now I don't get to include the vertical asymptote, so my solution to this problem would be -3 to -2. The -3, which is a 0, gets to be included. The -2, which is a vertical asymptote, never gets to be included. So that is the solution to that problem. And this concludes our lesson on polynomial and rational inequalities.